have you informed it, ma'am?
Okay. Is my screen visible?
Yes, ma'am.
Okay, so today I thought that we'll solve a few questions from whatever we have read, and before that, you should know about the defects. So there are mostly four type of major defects that are formed during the rolling. First is wavy edges. If your edges are having this kind of pattern, and second is zipper cracks in the center, like in center some zip kind of cracks will form, so that is also a defect in rolling. Then the edge cracks, like if there are some cracks on your edges, and then the alligator. So these kind of defects we have seen like how they look like. So what is the reason behind these defects that is in the ppt, like what why edge cracks are being formed during the rolling? Because of secondary tensile stress that can be induced at the workpiece. So suppose there is a uneven kind of heating or uneven rolling is being done, or you're doing excessive squinching, so some secondary stresses will be induced in your work, so that will cause edge cracks. Then the wavy edges. So wavy edges are very common. So it happens, it is the most common rolling defect, and it is happened because of the fiber at the edge. So uh, so what happens, suppose you're rolling and your elastic deformation is higher. So you have rolled, you're doing plastic deformation, but some elastic deformation happened, and some elastic recovery happened, and that is why it is trying to regain the shape, that original shape little bit, and because of that some wavy edges will form, unevenness will form. Then the gator cracks also. This is also very not so common, but it is very common in the sheet metal or continuous casting. Uh, so this is because of non-homogeneous flow of materials. So small words that you should know. Mostly in gate, uh, two type of question they will ask you. They will give you different kind of defects name, and they will ask you in what kind of forming process, what kind of defects will be formed. Second, they will give you different defects name, and they will ask you what is the cause behind these kind of defects. Then zipper crack, that is the small cracks in the middle which are formed during the rolling. So why it happens? If you'll it will happen if you'll give the high rolling pressure. So some compressive stress at the edge, and tensile stress at the center will be formed. So you refer these notes to understand what kind of defects are formed in the rolling. Forging, mostly these are the closed die forging defects. Open die, mostly only one kind of defect will form, that is barreling. What does that mean? Suppose you're trying to deform, plastically deform this one, but you have your material is it's what we can say, it's formability is not so good, and the application of your pressure is not proper. So then your material will start flowing like this kind of shape will form. So this kind of defect we call as barreling. This defect is common for open die forging. This is open die forging. This is what, this is cold die forging. So in cold die forging, mainly cracks will form, and then we have seen for flash and gutter. So suppose if your gutter is not if your flash is not proper, if your gutter is not proper, so these kind of defect will form. And if you haven't designed your die properly, we have seen few condition to design a die. So if you haven't designed your die properly, so your web can buckle also. So these kind of defects can form in what we say closed die forging. Then let's start solving few questions from these topics. So you please try to solve this question. We have seen questions from 2022 year. Let's start these questions. Please try to solve this question. Let me know the answer.
Ma'am,
Yes.
3883.5.
Wait, I'll check.
D, ma'am.
Yeah, option D is correct. So what is given in this question?
Initial volume equal to final volume by.
Yes, yes. So you have to follow continuity equation, which is H1 B1 L1 is equals to H2 B2 L2. So suppose what is it given? H1, that is your thickness is given as 50 mm. B1 is given as 250 mm and length. L1 is given as 3600 mm. Then H2, a rolling operation on the slab reduces the thickness by 10%. So 10% mean your H2 will be 0.96 of H1 and then and increases the width by 3%. So your B1 will be B2 will be 1.03 into B1. Then they are asking to calculate the L2. Now we will fill the values. 0.9 to H1, 1.03 into B1 into L2. So your L2 will be 3600. This is what? This is H1 and this is B1 only. So it will be 3600 divided by 0.9 into 1.03. It is coming D, right? L2 will be 3883.5 mm. Okay. Now solve this question. Okay, let's read the question. A 20 mm wide plate having a thickness of 200 mm wide plate having a thickness of 20 mm is fed through a rolling mills with two rolls. The radius of each roll is 300 mm. The plate thickness is to be reduced to 18 mm in one pass using a roll speed of 50 rpm. The strength coefficient of the work material flow curve is 300 MPa and strain hardening exponent is zero point 0.2. The coefficient of friction between the rolls and the plate is zero point 0.1. If the friction is sufficient to permit the rolling operation, then the roll force will be. So firstly, we will write the whatever the data is given. Firstly, your width is given, then your thickness is given, radius of roll is given as 300 mm. Then delta H, they are saying delta H will be 20 minus 18, that is 2 mm, or let it write as T because I have taken as T. So it will be T1, your T2 is given as 18 mm. Then K is given as 300 MPa, N is zero point 0.2, mu is zero point 0.1, zero point 0.1, and N is 50 rpm. Mu is okay, everything is here. What is it asking? It is asking you to calculate the roll force. So what we have seen, what is the formula for roll force? That is sigma average into projected area. Okay. So whatever what is the formula for sigma average? Does anyone remember?
Yeah, kfn by 1 plus n.
Hmm. Right. So for this you have to calculate epsilon also. So initial height is given, final is given. So it will be ln 20 by 80. Okay, what is your two strain?
Point
Calculate this point
105.
105. Now we will calculate sigma average. K is already given 300.105 and exponent is given as zero point 0.2. What is your sigma average here coming as? Calculate.
Ma'am, denominator is 1.105 or 1.2.
N plus 1 it is, right? Okay, sorry. It will be 1.2.
159.29.
Okay. Sigma average is 159.2829 MPa. Then what else you need? You need a projected area. So projected area is what?
W and 12.
Yeah, this area we need. So it will be length, projected length multiplied by width. What was the formula for LP? Under root R delta H,
Delta H.
and width is given as, okay, let it write it as W 200. So what is your projected area coming?
.5 almost.
Area.
Yeah, ma'am.
Sure?
I'm getting 4899. No, ma'am. No,
Yeah,
ma'am. Wrong.
yeah. You have calculated length only, right? So 4899 square is your projected area. Now we have sigma average, we have a projected area. Tell me the force in kilonewton.
780.36.
Yes, ma'am.
Correct. So
Same.
your option A is somewhat near to your answer. So your option A is correct. Okay, any
Um,
doubt in? Yes.
Ma'am, that friction which is given, that is no need to use, is it?
No. See, friction we didn't need to use, then roll speed also. They will provide you some extra data that is just to confuse you. You may feel we need to use it and all, but we don't need to use all these data. Okay.
Okay.
Okay. Any doubt
And
in this?
madam,
Yes.
uh, true strain is final length upon initial length, na?
Yes.
ln final length. And
Yes.
here we have taken ln of original thickness to final thickness, means
Yes.
big to small.
Yes. See, in last class we have discussed, see, that initial, final upon initial length, final upon initial. It was for length because your length will increase, right? Here your length will increase, right?
Yes.
One more formula is there for area where it was A initial upon A final. Why we do that? Because your area will decrease. So here your thickness will decrease. So when it is decreasing, you have to take initial upon final. And when it is increasing, you have to take final upon initial. You have seen this formula also, right? Is equals to ln L upon L naught is equals to ln A naught by A is equals to 2 ln D naught by D, right?
Yes, ma'am.
So when it is increasing, it will be final upon initial. When it is decreasing, it will be initial upon final. Any doubt? Or you can use this only, but then your answer will come in negative because we are doing compression. That is why it is decreasing. Then you have to ignore that negative.
Okay, ma'am.
Okay? Okay. Okay, any doubts in this? Okay. Solve this question.
D.
Yeah, D is correct. So let's read the question. A strip of thickness 40 mm is to be rolled to a thickness of 20 mm. So your initial thickness is 40 mm and your final thickness is 20 mm. Using a two high mill having rolls of 200 diameter means your radius will be 100 mm. The coefficient of friction mu will be what? And arc length in mm respectively r. So we have that formula that delta T is equals to mu square R or delta H. Let us write it as H. Delta H is equals to mu square R. So what will be delta H here? 40 minus 20, that will be 20. It is 20 and your R is given as 100 under root is equals to mu. So your mu will be around 0.447. Then what else it is asking? Length, arc length. So for arc length, we know the formula L is equals to under root R into delta H. Again, R is 100 and delta H is 20. It will be 2000 root. Then it will come as 44.72 mm. So your option D is matching. Okay. Uh, Tell me the answer for this question. Okay. How many of you know knurling and chamfering? That I feel that you can guess about roll forming and okay.
Knurling.
Yeah, knurling is the answer. So let's see first what is knurling, what is chamfering. So what is the question? The cold forming process in which a hardened tool is pressed against a workpiece. So in roll forming also a tool workpiece will be pressed against the tool, and when there is a relative motion between the tool and the workpiece. So there will be a relative motion between the workpiece and the tool, right? In the roll forming also, so any kind of rolling it will be there. The answer will be in to produce a roughened surface with a regular pattern. So these two will be eliminated because you will not get any pattern during these kind of forming processes. Next, knurling and chamfering, I'll show you by the image what is knurling and what is chamfering. This is a picture of knurling. So this is your workpiece. There will be a relative motion between the this is your tool. These two are your tool. There will be a relative motion between your workpiece and your roller, and this kind of a pattern will be already formed on your tool that will make a pattern on your workpiece. So this process is called as knurling. Then this is your chamfering. This process is called chamfering. So I'm showing the image of beveling also because chamfering and beveling is somewhat similar, but the difference is in the end product, like what kind of profile you want. If this kind of profile, if only one edge you're doing the deforming, then that is called chamfering. And if you're making a slope throughout the thickness, that is bevel. So this is your chamfering process and beveling process. Your tool will be moving here. Your tool will be moving here. So there will be a relative motion between chamfering and beveling. So now we can answer this question that option C is correct. That is knurling. Any doubts? Okay. Okay, then solve this question.
A.
Ma'am, D.
Yeah, D is correct. So let's read the question. The maximum reduction in cross-sectional area per pass of a cold wire drawing is this. This is the maximum reduction where N represent the strain hardening coefficient. So for the case of perfectly plastic material, so what will be the N for perfectly plastic material?
One.
0, ma'am.
0.
Yeah, 0. See, n tells you the slope of that curve within plastic region. So when your material is perfectly plastic, what does that mean? That means you're increasing the at one constant stress, your strain will be increasing. So we can assume somewhat like this your curve will be. So what will be the slope when your curve is like straight line? 0, right? So for perfectly plastic material, your n will be 0. So I assume that you know that strain hardening concept. Now we will fill the value here. R is equals to 1 minus e to the power minus 1. When you will put the value of e, it will come something like, yes. Okay. Okay, then next move on to next question. Tell me the answer of this question.
Forming.
Yeah, correct. So,
Welding.
yes.
Welding can also give strength. No?
Yeah, but which of the following process, if welding we will do, then heat effect zone will be arrive, and lots of other factors will be there. So they are asking what process will give you the highest strength. So that is metal forming. If you are forming, why metal forming will give you the highest strength? Can anyone tell?
Because of strain hardening.
Yeah, correct. Because of strain hardening, you will plastically deform your material, so there will be strain hardening. In the name itself, your material will be hardened and strong. So that is why option C is correct. Now solve this question.
C.
Yes, C is correct. So engineering strain is given as, oh, let me write it as this only, 0.1 divided by 100, that is 0.001. Then they are asking you to calculate the true strain. So true strain is ln 1 plus engineering strain. So it
Yeah,
will be
extra.
ln 1 plus 0.001 ln 1.001. So it will be 0.00099, and your answer is in percentage. Then we will multiply by 100, then it will be 0.099%. Okay, now solve this question. This kind of this on one formula, this kind of questions are very famous for the rolling operation. So one or two question on this, or maybe on separating force, or maybe they'll ask you to calculate torque. So two or three formulas which are very important in your rolling. I will upload the short notes also. So whatever the formulas which are mentioned in the short notes, definitely you have to learn those formulas. So this question.
A.
Yes, A is correct answer. So let's read the question. In a rolling operation using rolls of diameter 500 mm, if a 25 thick plate cannot be reduced to less than 20 in one pass, the coefficient of friction between the roll and the plate is. So you know the condition for this, that mu square r will be delta h max. So your delta h max is here 5 that is 25 minus 20 5 so it will be mu square will be 5 and your diameter is given as 500 so your radius will be 250 then you will calculate so your mu will come 0.1414 your option A is correct.
मैम वो जो मी इक्वल टू टेन अल्फा होता है वो किस केस में होता है?
Mu is equals to tan alpha. See that is different things. One like a few more thing that you should know about rolling mechanics that I have left now. That you should know forward rolling to move your sheet towards forward. If mu's will be less than 10 alpha, then your sheet will not move forward. So that is the condition for that. I will in next class I will tell you few more things like slip and backward tension, forward tension, backward slip and forward slip. So this formula is for to make your if your mu will be less than 10 alpha, then it will not move forward. Okay, your sheet will not move forward. That formula is for this. Okay,
म्यू ग्रेटर और लेस?
less than. Sorry. Okay, solve this question.
सी.
Yeah, correct. There's no doubt in this, right?
Yes,
It
ma'am.
is undergoing plastic deformation, so the exponent will be in between 0 to 1.
Ma'am,
Yes,
if coefficient of friction would be the greater than 1, then what would it happen?
greater than
1.
coefficient of friction. You're asking in rolling.
Mu.
Mu means coefficient of friction. In which condition? Rolling condition.
Yes, ma'am.
Then your sheet will not move forward, right? There will be lots of friction. So it will not
Hmm.
allow your sheet to move forward. That we don't want, right? It should move forward. It should roll.
Would it be blanking like at the beginning of the class and the fault you showed to us?
Sorry.
Actually, would it be blanking shape or alligator shape? So that's what I was. Okay, ma'am, got it, ma'am. Got the answer.
Okay. Okay. Solve this question.
0.187%.
The answer is final dimension
0.18757 mm.
757 mm.
मैम मेरा 99.81 mm आ रहा
99.81
है.
mm.
Oh, ma'am, I forget I have to add something.
Okay, then it will be add and tell me
95.1875.
95.1875. Okay, let's read this question. The flow stress of a material is given by this. So flow stress we will use wherever will be the plastic deformation, where epsilon is true strain. The Young's modulus of elasticity of the material is 200. So E is given as 200 GPa. A block of thickness 100 mm made of this material is compressed to 95 mm. So your H1, H initial is 100 mm and H final is 95 mm. Then the load is removed, then the final dimension of the block. So after removal of the load, there will be some elastic recovery. So whatever the elastic deformation that is being done in your material or workpiece, that will be recovered. So what we have to do in this question, we need to just find the elastic recovery and then we will add that recovery because it will recover, so it will increase, so that we will add to our final thickness, final height. Okay, so let's first to get the elastic recovery. So what is the formula we used during the elastic zone stress strain? Okay, this is the
Um,
relationship during the elastic zone. So we need to find your final dimension from this formula, but we need to get the stress. Okay, Young's modulus is given, stress we don't know what or how much stress they have applied, so that we can get from here. So here also what do we need to find? We need to first find the true strain. So your true strain will be okay. Let's fill the values in the formula. Sigma is equals to 500 multiplied by 100 divided by 95 into zero point 0.1.
मैम नेचुरल लॉग भी यूज करना है.
Sorry. Okay. What is your flow stress coming?
371.51 MP.
371.51 MPa. This is your sigma. Now from here we can calculate your sigma. Now fill all these values in here. So it will be 371.5. Your E is in GPa, so we will convert it into MPa and simply write it as epsilon. What is your epsilon coming? 0.000. Strain is 18575. It's fine, right? Then what we have to find? We have to find the strain. So it will be final.
मैम एक जीरो ज्यादा लग गया लग रहा है.
Okay. Let me check 0.001. Yes. And then it will be 0.001857. And final upon 95 will be e to the power 0.001857. When you will calculate this, it will come around 95.17 or 18. It will come on around like that.
मैम ये जो स्ट्रेन 0.00 ये वाला तो रिड्यूस हुआ है इतना तो एक्चुअल वैल्यू से
Reduce, see your recovery means it will increase, right?
यस मैम
So L final is not L
ओके
final means whatever the final dimension that I have written L final. Your initial will be here we are doing initial upon final only. See, when we were doing plastic deformation, we started 100. We started at 100, then we did plastic deformation, then there will be some elastic deformation, and then we reach to 95, right? But after removing the load, it will again go back. It will again go back to some value. So this value will be your elastic recovery. So this is increasing, right? This dimension will increase. What was your doubt? Is your doubt clear?
हाँ मैम आ गया
Okay. Okay, any doubt in this? Okay, we'll solve this question. Curious, we have 5 to 10 minutes only. Solve this question.
Madam, in previous question, the stress strain relationship, strain is engineering strain.
Where?
Sigma is equal to epsilon E.
See, this is for same relationship in elastic zone. If you are looking, you can use this as engineering stress, and then you have to use it as engineering strain. Here what we calculated was applied stress, flow stress, that is the true stress. So you have to use true here only. Now you got the true load. Okay, what we do in engineering, we take instantaneous. The relationship will be same for the elastic zone. This will be same. If you want to use engineering, you will use engineering. If you want to use true, you will use true. You understood? You are asking why we are taking true in this formula, right?
Yes, ma'am.
That is true. This formula is correct for both. If you are going for engineering stress and strain relationship in this elastic zone, this will work. And if you are going for true, this will work. But what here it is, what we got due to flow stress is true. That is why we are using true.
Okay, ma'am.
Okay. Okay, solve this question.
बी
Yeah, B is correct answer. So this is, if you will try to solve this question, this is aptitude based question, right? They are giving you the fractional reduction. What is the formula for it? This is totally apti based. This is nothing for forming. So I think you will be able to solve, right? Or should I solve it here?
No.
Say yes or no.
Please, ma'am.
No.
We can move forward.
Okay. Okay, solve this question.
Sorry, no, ma'am. I'm not able to solve previous question. Please.
This question? Okay, we'll solve. See, let's read the question. In a two-stage wire drawing operation, the fractional reduction, which is ratio of change in cross-sectional area to initial cross-sectional area, in first stage is 0.4. The fractional reduction in the second stage is 0.3. So overall reduction they are asking. So what happened in this? Suppose you're drawing a wire, sorry, you're reducing the cross sectional area. What we do while drawing, we are reducing the cross sectional area. So it is a two stage. We did it in the two stage. In first stage we have reduced the area, that is fractional reduction is 0.4. Then we performed one more stage and then we removed 0.3. So it is asking, suppose it was firstly like this, then it was firstly like that, then you reduced a little in first stage, then you reduce a little in second stage, and it is asking what will be the overall fractional reduction. So in first stage it was 0.4. Suppose your initial area is A, so the ratio of change in cross sectional area, we are taking it as delta A1 divided by A. So your delta A1 will be 0.4 into A. This is your change from first area to second area. So what will be the area after first stage? That will be A minus 0.4A, right? This much is the reduction. So your area is now, suppose it was A before, now it is A dash. So it is now 0.6A, right? Now we will move to second stage. In second stage, your fractional reduction is 0.3. So what we will say, change in the area and change in the cross sectional area divided by initial. Now your initial will be this area, A dash. So we will write it as 0.6A. So the cross sectional change will be 0.6 into 0.3 into A, that will be 0.18A, right? So how much area is remaining? Your remaining area after the second stage will be 0.6A minus 0.18A, that will be 0.42A, right? Uh, now overall reduction. What is your overall reduction? So now this much area will be left after your second stage. You are getting right? Then after we have to find the overall fractional reduction. What it will be? Overall change in the cross sectional area upon initial. So initial we know is A. What will be overall? That is A minus 0.42A. So it will be 0.58 divided by A and multiplied by into A. So your answer will be 0.58. Any doubts?
No, ma'am.
Okay, solve this question. Okay.
A.
Yes, A is correct. So you can use any formula to solve this question. Let's read this question. In a slab rolling operation, the maximum thickness reduction delta H max, the formula is already given, is mu square r, where r is the radius and mu is the friction of mu is the coefficient of friction between the roll and sheet. If mu is 0.1, the maximum angle subtended by the deformation zone at the center of the roll point. So either you can solve it by delta H max is equals to D into 1 minus cos alpha. This is one more formula where mu is given, D is given, and you can okay, these two you can combine and you can find one more formula you can use. That was for your projected length. Your LP is what? R sine alpha is equals to under root R delta H. This also you can do. So it will be R square sine square alpha is equals to R delta H. R and R will be cancelled. From here you can find delta H, which is mu square r. Again r and r will be cancelled. It will be mu is equals to sine alpha. Mu is 0.1, so alpha will be sine inverse 0.1. So alpha alpha will come as 5.739. You can use this also. This two relationship also you can use. Okay. Okay, tell me answer of this question. Then we will end.
C.
See, correct. This is simple relationship between true stress and true strain and engineering strain. Okay,